We are designing an educational building, a school, which can accommodate 1,500 students between the age of 3 and 18 from over 40 countries. We are aiming to provide an inspiring and challenging learning environment for students based on Passive House standard. The college is located in Bristol, UK. The total set area is 100,000 square meter and the total building gross area is 25,000 square meter. The temperature typically varies from 3 degrees Celsius to 21 degrees Celsius and is rarely below -3 degrees Celsius or above 27 degrees Celsius. It's usually cloudy or overcast throughout the whole year except summer. The design strategy is based on energy hierarchy. First step is reducing energy demand, then use energy efficiently. Finally, use renewable energy and low-carbon technologies to cover part of the energy consumption or even all of them to make a zero-energy building.
Each building has been broken down into several distinctive blocks, married together with a central hub space, which delineate a clear circulation strategy around the building. The extension of the central hub space also built a connection with the surrounding buildings. Our first proposal is using repeating modular blocks. The shared school is in the middle, surrounded by the repeating primary and secondary blocks. It has clear layout and flexibility for future development. You just add the repeating blocks to satisfy the increasing number of students. However, this plan seems like has less connection between one block and another. That brings us the second proposal. We combine the repeating blocks by the central hub space as mentioned before, but the straight line layout still lack of connection. Therefore, we rotate the orientation of primary and secondary school and add links between each building. The curved layout making all schools point to the main entrance of the creative college, giving a sense of embrace and community. The primary school located on the west of the college. Next to it is the shared school for communication between different levels of students. It includes library halls and canteens. The secondary school is on the east of the site. The sports hall and swimming pool are separated from the shared school. It has individual HVAC and electricity system. On the one hand, it has different energy demands such as hot water, ventilation, and so on. On the other hand, when the school is closed for holiday, the sports hall and swimming pool could still be operated and open to the public. The function of each building are quite clear. The middle part are the central hub space for communication between students, teachers, and parents. Canteen and specialist teaching areas such as for art are requiring more natural light than other rooms. Classroom and the library need sufficient diffuse light without glare. As for the hall, such as theater, natural light are restricted. Located in high latitude, the site has high sun angle in summer and low one in winter. Therefore, windows need special design to shade in summer and acquire enough solar gain in winter to decrease the energy load for heating and cooling. We have several proposals for window shading. The first is the overhanging for south and the vertical shade device for west. Another is using the thickness of the wall itself as for shading. And the final proposal is the projecting window. After the simulation, the projecting window performs best on both daylighting and shading among all proposals. It can provide self-shading at the first place. It can also reduce the solar transmission of glazing due to the increase in solar angle of the incidence.
Daylighting is a crucial part in our design. We use rooftop lighting in corridor to get more sunlight, and large windows are installed in the north facade of the building to maximize the use of daylighting without glare. What's more, the glass partition wall allows reflected sunlight from rooftop lighting to get into the classroom, which can reduce electricity demand both in classroom and corridor. The college used timber frame construction and infilled with straw bale as insulation. The structural wall always has weatherproofing and vapor control membrane to improve the thermal performance, and lime render can give a high wear resistance. Both the timber and straw bale are widely available from local sources and has low environmental impact. Straw bale has great heat and sound insulation. It has long lifetime, can avoid thermal breaching, and affordable. The structural wall can be supplied by local company with a really low U value of 0.13 watts per square meter Kelvin. And we use the triple glazed window filled with argon or other inert gas and with coatings, which can give a low U value of 0.69 watts per square meter Kelvin or less. All the fabric U values are low enough to provide a good thermal performance. The primary energy demand of typical school is 140 kWh per square meter per year, but our creative school can reduce the energy demand to 82 kWh per square meter per year, which means the passive house standard that is less than 120 kWh per square meter per year. As for renewable energy and low carbon technologies, we use PV panels, ground source heat pump, and combined heat and power to cover part of energy consumption. And rain-harvesting system is used for flushing toilets and irrigation to save water.
Our design achieves the standard of passive house, which reduces the energy demands and the corresponding carbon emissions. We hope it can provide a productive study environment, as well as promote the communication among students, teachers, and parents.